Welcome back, students. Today is the session 13 from the chapter of laws of motion, and this is the Q&A session in which I have taken one question which was asked in the IIT-JEE mains examination in 2013. So the question here is, two blocks of mass small m and capital M are they connected by a string of cross-sectional area A passing over a frictionless pulley as shown in this figure. This system is released from the rest if m is equal to m by 2, or we can say that m is equal to 2m. Then the stress produced in the wire or the string is 2 mg divided by 3a, b is 4 mg upon 3a, c is gm upon a, and the fourth option is 3 mg upon 4a. So we have to find the correct option here. Now when this system is released from the rest, since this block is heavier, because capital M is equal to 2m, that is the mass of this block is more than the mass of this block. So this block will go down and this block will go up. Okay. So now, as we all know that tension always acts away from the body. So the tension in this wire or the string will be, for this block it will be in this direction, and for this block that the tension will be in this direction. That is, it is acting away from the block. The weight will be acting in the downward direction. The weight of this block is equal to m into g, and the weight of this block will also be acting in this direction, which will be equal to capital M into G. So like this, capital M into G. So now when this system is released from the rest, because this is a heavier block, therefore this this block of mass m will go up and this will go down. So so in this case, now the first case here is that since this block is going up, then it is possible only when the tension in the string is more than the weight of this block. That is, block M will go up if T is greater than, that is the tension in the string is greater than the weight of this block. Or we can say that is the net force on the block of mass m. Net force on the block of mass m in the sorry, net force on the block on the mass m will be equal to T minus mg, and this force will drive this block in the upward direction, that is in this direction. So now let us say the acceleration of this system is a, that is the acceleration of this system is a, that is this block of mass m is moving in the upward direction with an acceleration a. So this block, that is the block of mass capital M, this will be moving downward with the same acceleration. So if this block of mass small m is moving upward with an acceleration a, then in that case the T minus mg will be equal to, if the acceleration of this system is a, so this will be equal to, this is the net force which is acting on this block in the upward direction. So this will be equal to T minus mg will be equal to m which is the mass of this block, into the acceleration. So this is the first equation which I have got. Okay. So now I will be taking the second case, that this block of mass capital M is going downward. Now this block will go downward only when the weight is more than the tension in the string. So the net force which is acting on this block will be equal to mg minus t, and this force will be acting in the downward direction. So the net force on the block on the block of mass capital M. Net force on the block of mass capital M, this will be equal to m g minus t, and this force will be acting in the downward direction, and this block will also move with the same acceleration, that is a. So we can write this. It implies that now m is equal to 2m. So I will be substituting this m is equal to 2m in this equation. So I will be getting that 2mg minus t. Now the tension in the, since this is a both these blocks are connected with the same string or the wire. So the tension in this string or the wire will be the same. It will be the same for both these blocks. So 2mg minus t is equal to, now the mass that is equal to m into a. Now m, capital M, is equal to 2m. So I will be substituting as 2ma. So this is the second equation. So I have got these two equations now, and with the help of these two equations, I will first of all calculate the tension in the string or the wire. So I am going to write both these equations here now. That is T minus mg. T minus mg is equal to ma, first equation, and second equation is 2mg minus t is equal to 2ma. So this is the second equation. Now what I will do is I will just multiply this equation 1 by 2. So what I will be getting is, that is 2t 2t minus 2mg is equal to 2ma. What I have done is I have multiplied this equation 1 by 2, and the second equation I will keep it as it is. 2mg minus t is equal to 2ma. Now if I divide both these equations, then what I will be getting is 2t minus 2mg upon 2mg minus t. This will be equal to 2ma divided by 2ma, that is equal to 1. So it implies that 2t minus 2mg is equal to 2mg minus t. So it implies that this t will come on the left hand side of this equation, so I will get 3t, and this will go on the, this 2 and minus 2mg will go on the right hand side of this equation, so it will become 4mg. So it implies that the tension in the string is equal to 4mg by 3. Okay, so the tension in the string is equal to 4 mg by 3. So I will write this value here. I'm just writing this value here. that is the tension is equal to 4 mg by 3. Now we know that we have to find the stress which is produced in this wire or the string. So the stress is equal to force or tension. Tension is also a type of a force. So force or tension divided by the cross section area. So the stress which is induced in this wire or the string will be equal to, now tension, that is equal to 4 mg divided by 3 divided by A, which is A is the cross section area of this string or the wire. So the stress which is induced in this wire or the string is equal to 4 mg divided by 3A. So the correct option is B, that is 4 mg divided by 3A. So here, so this question was asked in the IIT-JEE mains examination in 2013. Now here the question was very easy. The only thing which you have to remember is, the first important point which you have to remember is that the tension always acts away from the body. And second point, this block will go up only when the tension in the string is more than the weight of the body. This block, that is the block of mass capital M, will go down only when the weight of this block is more than the tension in the string. So based on these two concepts, I was able to derive two equations, and with the help of those two equations, we were able to find the value of the tension in the string. Now, once you have calculated the tension in the string, then stress is equal to force or tension divided by area. This is the formula for the stress. So I have substituted the value of the tension in this equation. That is, stress is equal to force or tension divided by area. So I got this answer as 4 mg divided by 3A. So the stress which is induced in this wire is equal to 4 mg divided by 3A. And the correct option is B. So thank you very much for joining this session, and in the next session I will be coming up with some similar questions. So till then, have a nice day. Bye.